Hello everyone, welcome to the Study Hacks Institute of GIS and Remote Sensing. Today I will try to discuss a very important topic, mainly how we can easily use the kernel in Google Earth Engine. I try to give a full description about the kernel and how we can easily use the different types of kernel in Google Earth Engine. So basically in image processing, changing pixel value based on neighboring pixel is a powerful technique for enhancing, smoothing and analyzing image. A common approach to achieve this through the use of kernel. And kernel help you to affected by averaging, effacing or detecting the pattern with an image we can easily get from the kernel. So in this tutorial, I will try to discuss about that the full topic of kernel and how we can easily apply the kernel and to get the more better image for the different purpose. So first of all, kernel is a small matrix of number used in image processing to filter or modify an image. And kernel in Google Earth Engine are typically used for smoothing image, mainly reducing the noise, sharpening image, mainly enhancing the edge, and detecting the feature, finding the edge or specific pattern. And kernel moves across each pixel in an image and apply the mathematical operation based on the kernel values. So in Google Earth Engine, you can find out the ee.kernel. So under this function, we find out all of kernel functions. So different types of kernel function you can see. So I will try to explain this type of kernel function, how we can easily use and get the more better imagery. So here I already make an image. So this is the original image. So now in this image, I try to show you that how we can easily apply the different types of kernel. So first one is that mean kernel. Mean kernel is used to reduce the noise in an image by averaging the nearby pixel values. So in the mean kernel, it's a great for smoothing out of small details, making the image look clear image we can easily get from this mean kernel. So applying the mean kernel, we are just use here this function. You can simply that ee.kernel square. This function we have used to create the mean kernel. There you can see ee.kernel.square. Then we find out the radius, then unit, normalized, and magnitude. This type of information in this argument. So radius to the kernel to generate, you can simply put the radius and then put the unit. Basically, is the pixel. This is the unit about that. So using this ee.kernel square, we can calculate the mean kernel. So let's go try to do it for the mean kernel. So for that, just take a variable. I put the variable name, suppose mean kernel. So now apply this function ee.kernel dot square. And now if you check all of arguments, so basically you find out that radius, unit, and normalize and magnitude. So basically this radius and unit very important. This kernel square function. So we define it for the radius. Suppose I put the radius 1. Radius 1 means that it's a 3 into 3 kernel. We create this 3 into 3 kernel. When you apply the 1, then unit, I set the unit as a pixels. So just you can write here pixels. Normally it's not need, remove the and magnitude not need, just remove that. So in this case, I just create a kernel. Mainly it's a mean kernel we create. Mean kernel basically it's help you to get for smoothing out small details, making the image look clear and less grainy when you want to apply the mean kernel. So this is the function we apply ee.kernel.square and I put the radius 1. It means that I just put here 3 into 3 kernel and units mainly pixel I put in here. So now apply the mean kernel to smooth the image. We have to use the convolve function. So this is the mean kernel I created. This mean kernel I want to apply on my image. This is my image. I already get an image in my Google Earth Engine code editor. So now just try to apply it. So apply this mean kernel to the smooth the image. So for that, just take a variable. I put the variable name, suppose you can put in name. I put the variable name, suppose smooth, and then call my image. This image I already created. Basically, this is original image. This original image I want to apply the mean kernel. So for that, just use a function convolve, and then call this mean kernel. Simply copy this function variable name and paste here. So now this is my original image. I just create the mean kernel, and now I just apply the convolve function and call this mean kernel. So now it create the smooth image. So now try to add the visualization of this image. So just as here map dot add layer and call this variable name smooth and click the run. So it look like that. So try to add the visualization from here. So I put here suppose red, then green, and blue and stressing. I put here suppose 98% to get the more better visualization. So now further apply and then import, further copy this variable name from here and add after the object name. Just add in here and put the name. Suppose it's a smooth image. Okay, so now we find out that two imagery we try to add in here. One is the original, mainly normal image. Another is the smooth image. So you can see what is the difference between these two imagery. Okay, so in the basically this mean kernel is used to reduce the noise. It reduces the noise from your satellite imagery, and by calculating the averaging nearby pixel values, and it's a great for smoothing out small details, making the image look clear and less grainy. With now this image look more better. So now if you want to work with for the different types of remote sensing work also. So this is the one practical example how we can easily apply the mean kernel and how we can easily create that more better image. Okay, so reduce the noisy pixel and by averaging nearby pixel by calculating that, and it's a we can easily remove all of unnecessary pixel and image look more better, and we can find out remove all of grainy pixel also from here. So this is the mean kernel example. Basically in this time we just put at the radius 1. It means that 3 into 3 mean kernel is smooth out a small fluctuation in pixel values and creating the clear image. 1 means the 3 into 3. And now we talk about the another one. It's called the Gaussian kernel. If you take it from here, you can see the Gaussian kernel, this one. So this Gaussian kernel is similar to the mean kernel, but use the weighted average. So in this case, if you want to use it, kernel Gaussian, so it calculate the weighted average, okay, and giving more importance to the central pixel, and it's open use for blurring or softening an image. So we try to use it for the Gaussian kernel. So for that same process, we try to apply in here. Just take a variable. Suppose I put the variable name is that Gaussian kernel, and now just call this function dot kernel dot Gaussian, and you can check all of argument. We find out that radius, then sigma, and also pixel. So just create a dictionary, curly bracket start, also curly bracket int. So first of all, radius. Radius, I just put the approximate size of the kernel. So I put the size of the kernel, suppose 3, and then put the sigma. I put the value for suppose 2, and unit. I set the unit for pixels, and it's not ready. Remove that. Also not remove. So now this Gaussian kernel, I'll just write the comment, then you'll get the more better idea. It's a Gaussian kernel. So now this Gaussian kernel, I want to apply on my image. So just I take a variable. Suppose I put the variable name is that blurred. You can put any name as a variable. Then call my image. And for applying, just put here the convolve function. Convolve and call this Gaussian kernel. Simply copy and paste here. So now try to take the result. So call the map.add layer and call this blurred, copy and paste here. So now also run the code. So it look like this type of result. I try to add the visualization from here. Suppose just click on here and I set suppose red and green and blue. Custom spacing 98%. And then further apply. Then import and copy this variable name. And after paste here and I put the variable name, suppose it's a basically we are using to get the blurred image. So just I put here suppose blur. So basically the Gaussian kernel create a soft blur. We find out this type of soft blurring here, you can see. And this soft blur help useful for highlighting the larger structure. We find out that larger structure in the image without the noise of smaller details. So that's why it's also very important. We can easily identify this type of blur. And from this blur, soft blur, we useful for highlighting the larger structure in the image without the noise of smaller details. So it's one kind of kernel for Gaussian kernel. We also apply to get that this type of soft blurred imagery get from here. And further, we also discuss about that another one. Suppose Laplacian kernel. So Laplacian kernel, I want to apply for here. Laplacian kernel. So this Laplacian kernel detect the edge by highlighting the areas where there is rapid change in pixel values. This kernel is used for edge detection and help to find the border lines with an image. So now try to apply the Laplacian kernel. So you can see here this function Laplacian kernel. So this Laplacian kernel generate a 3 into 3 Laplacian 8 edge detection kernel, and this kernel detect the edge by highlighting areas where there is a rapid change in pixel values, and this kernel is used for edge detection and also help to find out that border with line with an image. So now if you want to apply, suppose just copy this function Laplacian and paste here, and I put the variable name. Suppose I put the name suppose Laplacian kernel. You can put any name as a variable. So now e.kernel Laplacian 8. We set here that magnitude is not 8. So we try to put here this only for the following this function. You can easily find out that Laplacian 1. You can see the unit. So let me check. It's not it, just I remove it. We'll just put here that one argument for units, and I put here that pixels. Okay. So now apply the Laplacian kernel to detect the edge of this imagery. So just take a variable, suppose edge, is, and I call this image. After that, call the control and call this Laplacian kernel. We copy and paste here. After that, we try to display the edge detection image. So just snap dot add here and call the edge. We copy it run. Okay, problem. Okay, at the M. So basically, this function basically automatically create. Okay, you can see when you apply this function, it automatically create the 3 into 3 Laplacian edge detection kernel. So it automatically creates. So that's why you are not mentioning the this type of magnitude or normalized. We try to the optionality. Okay. So now it works, and we try to add the visualization for this and try to check the edge detection from this imagery. So just put here the red, then green, and also add the blue. Spacing of 98%, and then apply. So now we find out this type of edge. Get this type of edge from here. Also, this is the river. You can easily find out. So basically, this is the Laplacian kernel. Detect the edge by highlighting areas where there is rapid change in the pixel value. And this kernel mainly used for edge detection and also help to find out the borderline within an image. We can easily find out the borderline within this image also. So just I try to import these things, and now I want to just copy this variable name, copy, and then paste after the object name. Just paste here, and I put it. It's a is. We can easily find out that is from here. So this is the process to apply the Laplacian kernel and detect the is and also border. Laplacian kernel mainly highlight the area where there are a strong contrast and like border between the forest and water body or city boundary. We can easily find out this type of border using the Laplacian kernel. As well as we also use here the Sobel kernel. So now you talk about the Sobel kernel. So just write the comment for that Sobel kernel. So it's very important to detect the edge in a specific direction. It's commonly used in two variations, horizontal and vertical, making it ideal for detecting the feature like road, river, or boundaries that align in a specific orientation. So for that, just take a variable. Suppose I put the variable name Sobel kernel, and I call the ee dot kernel dot Sobel and put all of argument one by one. Here you can see basically magnitude and normalized. It's put here that empty. It's not need to mention in here. And further just apply the Sobel kernel to the detect the horizontal edge or vertical edge. So further just take a variable. Suppose I put the suppose horizontal edge, and now call this image and use the control with the Sobel kernel. Just paste here. So now it will be added. We try to check. So just put here map dot add layer and call this horizontal edge. If you want, you can also put here suppose in plus one and max plus one. Okay, and I put here suppose it's a horizontal. Out on the book. So now you can easily detect this type of border. You can easily detect. If you want, you can also stressing, then you also get the more better visualization. Suppose I put here that suppose near infrared, then red and blue, stressing suppose 98%, and then apply. So now you find out this type of imagery. So from this imagery, we can easily detect the Sobel kernel, highlight the horizontal edge, making it useful for detecting the linear feature like road or river. We can easily detect using this. So this type of kernel, so here you can see, first of all, we find out this type of normal image. So this is the normal image. So we are just applying the mean kernel. So basically mean kernel provide you the result for smoothing and reducing the noise. Reducing the noise when you apply the mean kernel. And we find out this type of imagery. If I zoom, you can see we find out this type of smooth imagery. For smoothing and reducing the noise, we are using the mean kernel. Then we also did about that blurred. So basically, it's provided the Gaussian kernel. So Gaussian kernel for use for blurring with a normal natural effect, and we can easily identify for large structure. So here you can see for this area, it show this type of value, this type of value. Okay, we can easily find out that it's using the Gaussian kernel. And then also we can see the Laplacian kernel we are used. So Laplacian kernel mainly for edge detection to find the border. You use here the edge detection and also find out the border. It also used for that. And then also Sobel kernel. Sobel kernel basically it useful for directional edge detection. Okay, directional edge detection we are using here this Sobel kernel for horizontal or vertical we can use. So kernel are very powerful way to process image in Google Earth Engine, and they open up a range of possibility for different types of analysis. We are smoothing an image, finding edge, or highlighting a specific feature. Kernel give you the tools that need dig deeper into the data and try experiment with this example. You also check this type of code and also try to use. So then I hope you can easily get this type of idea. Not only for that, you can see it also added the lot of kernel function. So different types of kernel. So basically we are use this type of kernel to image analysis, different purpose for image processing and changing the pixel values based on the neighboring pixel. We are use here that this type of kernel. So further next time I'll also discuss about this type of kernel, then you also get the more better idea how we can easily use to get the more better image analysis. So today is no more. In the meantime, I also give you an announcement for upcoming online training program. So basically, this class will be start from 13 December, and now this session is open. So if you want to join this online training program, you learn all of details in the Google Earth Engine, any kinds of function, any kinds of analysis. I hope after completing the total 7 days online training program, you can do. And in this online training program, you will learn everything from a beginners to advanced level. If you have no knowledge about the coding, mainly JavaScript or Python, or if you have no knowledge about the Google Earth Engine, don't worry about that. You will learn everything from beginners to advanced level. And in this online training program, basically it starts from the 13th December. So now registration the open. We take only for the 2 days class, Friday and Saturday in a week. Is day mainly 4 hours. This is the time about that. And this online training program, if you want to join, simply contact in this email. Also contact with this WhatsApp number. All of information you can easily get from the video description. You can also check all of course content. Okay, for first day, second day, third day, you can also check all of course content. And when you join this online training program, you also get some benefits such as course certificate after submitting all of assignment. You can get the materials, maybe slide or PDF. You can get the practice code. Also get the recorded class if you miss any live training, and also get that um lifetime teaching support. It's very important as a beginners, because as a beginners when you start the learning Google Earth Engine platform, you face a lot of problems. So that's why you need the continuous support. So we are also providing the lifetime teaching support regarding this online training program. And when you face any problem, you can get the support. So that's why you can smoothly learn all of things properly. So if you want to join and also take the 50% discount as soon as possible, complete your registration and join our live training session on 13th December. So today is no more. Thank you for watching that. Stay happy, stay safe.